All right, so in this week's video, we'll be continuing the project we started in the last video, which was assembling our aquaponics irrigation and watering system. This week we'll be building a automated control system using an Arduino Nano V3. This video will consist of 4 parts. The first of which is I'm going to describe my idea for the control unit and the circuit diagram. Then we're going to be testing that circuit on a breadboard. If that works, we will move everything over to a perf board and test it there. And finally, we will go through a short Arduino script that I wrote to run the control system. Assuming that goes well, we'll assemble everything and we will have finished the prototype for the Arduino powered Aeroponics control unit. Hope you guys enjoy. Here's a circuit diagram for the pump controller that I'd like to use. So we'll just run through it end to end here. I'd like to have a 12 volt, 3 amp power supply. I just want a single source of power. Now the Arduino is going to require 5 volts. So we're going to use a voltage regulator with 2 220 microfarad capacitors to smooth out the signal. So we have 12 volts coming in, a voltage regulator that steps down to 5 volts, and then powers the Pi over the 5 volt pin. A diode connected to the analog 5 pin that we can control programmatically. The Arduino grounded back to the 12 volt, the initial 12 volt power supply. And then, so in order for the Arduino to turn the pump on and off, which is a larger current than it puts out, we're going to use an electromagnetic relay. And a relay is just a device that allows us to control a larger current with a smaller one by running a 3.3 volt signal through a coil that generates a magnetic field that flips an armature, which will allow our 12 volt signal to run all the way out to the connectors to our pump. I'm going to add a fuse for safety reasons, obviously. And we will plug our pump in at the end of our circuit. I'd also like to add I'm just calling it a shortcut button, but essentially a push button connected to the 3.3 volt pin on the Arduino that will allow us to flip the relay, which will turn on the pump without having to run any code for testing purposes, just making sure everything's on. So that's the basic circuit. Let's put everything together and see how this runs. Okay, so we're going to solder the connecting pins onto our Arduino Nano V3. First pin went on pretty nicely. Just going to continue through the rest. The first row of connector pins has been soldered on. The connections look pretty good. This time around though, I'm going to solder directly onto the mat. When I was applying pressure to the pins, you heat up the plastic that the pins sit in, and if you push on them, they kind of sneak out, so you can see that these aren't an even line. So this time around, I'm going to place this directly on the mat, so even if I apply a little pressure, hopefully they won't get away from me. So let's see how that goes. I got both rows of the pins set. You can see the second row where I laid it on the mat. Looks pretty straight. It looks good. The soldering connections are okay. This side is a little more uneven, but that's all right. the connections will work. We've got our test schematic added to a breadboard here, and I'm gonna test it out and make sure everything works. Instead of the pump, I have a green LED as a stand-in with a couple resistors. Here we have our Arduino Nano V3, which will be the brains of the circuit. We have a 12 volt, 3 amp power supply. I have a voltage regulator to step down the 12 volts to 5 volts so we can power the Arduino over the 5 volt pin, which allows us to not require a separate USB power source for the Arduino. We have a mechanical relay here, which will allow the Arduino to control the larger current going to the pump from a smaller source, a 3.3 volt source that it puts out from one of the analog pins. So let's go ahead and start up our circuit. And like I was saying, we have 12 volts coming in, and a nice perfect 5 volts coming out. I've added a mechanical button here just to test that our circuit works, so we could even turn it on and off without requiring code changes. I have a feeling that this voltage regulator is going to heat up, so I think I'm going to have to apply a heatsink to it. But for the time being, everything seems to be working. Yeah. So I've added a heat sink. It's definitely overkill for the size of the component, but it's I had sitting around, so it's what we're going to go with. I'm going to plug this back into the circuit and leave the circuit running for a time and measure the voltage. And if we have a constant voltage, then this is dissipating those watts of heat energy away from our voltage regulator, which will maintain a stable current. Interesting. Boy, that immediately heated up. Why is that 7? Something smoking. So, I just killed this Arduino, unfortunately. It looks like I have fried the processor on this little Arduino, and I did that by plugging in this voltage regulator backwards. The voltage regulator was heating up, so I added this heatsink to try to help it wick heat away, which will allow it to do its job, which is maintain voltage and bleed off the excess watts as heat. And when I put the heatsink on it, I wasn't paying attention to which direction it faced. So instead of plugging it in this direction, I plugged it in this direction, which allowed about 8 volts to be drawn through the processor. And when you're powering the Arduino over the 5 volt pin, there is no resistor into the processor, so it burned up this processor, unfortunately. Lesson learned. Fortunately, I have a backup Arduino, so I will be soldering a new set of connector pins onto this, introducing the new Arduino into the circuit, and remembering which direction to plug in the voltage regulator. It's an unfortunate problem I had, but moving on. One thing we did learn is that this heatsink seems to be adequate. I've had this system running for several minutes now, and it is bleeding away the excess heat, and it's maintaining right on 5 volts. Which is exactly what we wanted. 12 coming in, 5 coming out, no diminished voltage. So, all done. Had a little more success this time. Pins are a little straighter. This one is a little turned, but that's okay. Soldering turned out pretty well. I'm happy with that. So now we're going to get into our circuit, which we know is working, and move on to the next step, which is testing our pump. Okay, so this is our dead Arduino. I'm going to add a little tape on here so that I don't mix the two up. Since this is already damaged, and since we know that it conducts the current through it still, I'm going to use it to test the circuit before I plug our brand new freshly soldered Arduino in. So here we go. Good ground, 5 volt. Here we have the 3-volt connection going out to the positive rail on this side, and then the A0 pin here. Yes, okay. So, and our voltage regulator facing the correct direction. Now we're going to add our 12 volt, 36 watt or 3 amp power supply. Lights on, circuit works. 12 volts as expected, and 5 volts going to our Arduino. Super. All right, we've got this set back in the right position. 3 volt pin here, A0, 5 volt. In this channel, the ground. Super. And our voltage regulator again, facing the correct direction. So here we go. That's good. I think we're up and running. 5 volts, excellent. All right, it only cost us one Arduino and some time resoldering, but we're back in business. And we've added a heatsink to our voltage regulator. So great, on to the next step of replacing our placeholder LED with the pump for our irrigation system and testing to see if everything's functioning properly. We have our basin that we constructed in the last video with our 1100 gallon per hour pump. We have connected that to our schematic that we've assembled onto our breadboard here. Instead of using the analog signal from the Arduino, we're just going to use the 3.3 volt current provided by the Arduino with the shortcut button that we added to the circuit. Super. So looks like the circuit works, everything's running, single source of power. We're going to move this schematic from the breadboard onto a perf board and run our prototype. Okay, so perf board prototype soldered together. Not the prettiest, but hopefully all the connections are solid and we can test this circuit out, which would be pretty exciting. So I'm going to
Plug the power supply in. We're going to take out, this is the dead Arduino, the one with the tape on it. We're going to put the real Arduino in. So, actually, you know what? I'm going to test this with the dead Arduino, just in case anything's on backwards. And we're going to see how this runs. Nothing. Okay, we've got current there, which is good. Okay, we've got current. Looks like the voltage regulator is supplying current as it should, but it seems like the Arduino is not getting power. Did we forget to supply the Arduino with power? No, I don't think so. I did. Okay, so what I just realized is, I'll use this as a example. We learned this lesson the hard way once. Okay, so I figured out what happened here. We know we had a current from our main power supply. We know the voltage regulator was providing 5 volts. What I forgot to do is essentially what this orange cable is, which is provides the Arduino with the 5 volt power supply after the voltage regulator. So I'm going to add one more connection. Good thing I didn't turn off the soldering iron. And then hopefully this circuit will work. All right, let's try this again. Let's see where we get. That's funny. Okay, well, okay. Couple things. Looks like we're getting power. Measure that. But it's funny, I think I heard the relay tick. Which is the opposite effect I'd like to have. I wonder why that's happening. Let's find out. All right, as we know, 12, more than 12, that's interesting. Right on 5, super. Of course, we're not going to see the light turn on and off because it's programmatically controlled. It's not actually built into the circuit. So we're just gonna cross our fingers and hope that works. It is interesting that you can hear it when I disconnect the power. I wonder. Yeah, I think I have wired that, unfortunately, backwards. All right, let's see. Let's find out. Well, a couple of things. I have put this button on incorrectly, so we're gonna have to fix that. I'm still not sure why the relay, as soon as it's powered on, it's opening the relay. Oh, you know what? I think it's because of the way I wired this button. Oh yeah, that's the problem. I'm gonna move the button 90 degrees, and I think that should solve our relay problem. Okay, let's see if that did it. Oh, yes! Very cool. Okay, so good news. We have wired up our shortcut button. I can hear the relay flipping. Let me measure and make sure that that's actually causing the 36 watt, the 3 amp, 12 volt signal to come all the way out here. These are the connection points we're going to use to plug in the pump. But this is good. That was a step forward. All right, negative, positive. Okay, so we have at least, this is the fuse, for safety reasons, obviously, that goes all the way to here. So we at least have 12 volts. All right, this is good. So maybe there's a faulty connection with my, oh, you know what? Okay, yes, I solder. This is another missed solder. So I'm going to move this connection over one pin, and that ought to do it. Okay. Yeah, that should work. Okay, easy enough. Okay, that ought to do it. We're going to plug this in and see if everything works. I see the power lights running. I can hear the relay. The thing I really want to measure is if we are getting 12 volts here, which is where we're going to connect the pump. So there. Oh, fantastic. Okay, so relay works. Hopefully, the one thing I haven't tested is whether the analog pins are connected, and I need to use the functioning Arduino to do that. But hopefully those connections are soldered properly. Okay. Here we go. Fantastic. So that indicator light and I heard the relay go means that our system is functioning. So we'll hit the reset just to do that one more time. Fantastic. Okay. Well, this prototype is ready to go. There's one additional component that I don't know if I mentioned earlier. This is a 5 amp fuse. Because we're missing electricity and water, or I think anytime with electricity, it's good to be safe. The pump requires a 5 amp fuse, so this is the only other component we didn't have on the breadboard, but everything's functioning and we're gonna plug in the whole system now.
The last part of our video, we're going to go through the script we wrote to run our controller. It's a fairly simple script, so I'm going to go through top to bottom. Let me make the font bigger so it shows up better on camera. Okay, so the first couple things we did were assign the pin numbers that we're communicating with the pump and the LED to. We assigned those pin numbers to variables. And we also assigned the lengths of time in our watering cycle to some variables. I find doing this to be helpful when your scripts get more complex. It's nice to have human readable variables instead of magic numbers floating around the code. Sometimes you can get confused and mix things up. For our purposes, you maybe could have didn't need it, but I added them anyway. We declare our pump signal, our LED, the time we'd like to pump, which is 45,000 milliseconds or 45 seconds, and the time we're going to wait between pump cycles, which is 15 minutes or 900,000 milliseconds. Setup and loop are required methods in any Arduino script. We need to do a couple things to the analog pins that we'd like to use, and we declare them as outputs. And this tells the Arduino that we definitely want to use 3.3 volt signal on the output of these two pins. So we did that here in our setup. And then I wrote a little start sequence, which just turns the LED on, off, on, off to let us know, hey, I've started up and I've gone through my start sequence. It also opens and closes the relay, which will start the pump, but only for 1 second, 1,000 milliseconds, so it won't actually push any water out. Let's go through our loop. This is the heart of our code, and it's fairly simple. Turn our pump signal pin on, which was the A4, and we turn the LED on. So we turn the pump on, we turn the LED on. We wait for the pump time, which is 45,000 milliseconds. We turn the pump off, we turn the LED off, and then we wait the cycle length, which is 900,000 milliseconds or 15 minutes. So very simple. Turn everything on, water for 45 seconds, turn everything off, wait for 15 minutes, start our cycle over again. So like I said, this is fairly straightforward, but it's adequate for our controller. In the future, I'm interested in adding some more advanced features, maybe a rotary encoder and a couple of screens that display what the pump time and the cycle length are, so you can manually adjust them without having to edit the code. But for the time being, this should be adequate. So we're going to compile our code, which it compiled, upload it to our Arduino. Everything looks good. And then move it back to the perf board for our final bit of testing.
Okay, and here we have it, the finished prototype. Sitting on my desk, everything's plugged in. We're going to hit the reset button on the Arduino now, which should start our cycle all over. There's the warm-up sequence. And our watering cycle. Just looking pretty good. Great. Look at that. Huh?
Okay, that's it for this video. I'm pretty happy with how everything turned out. We got the pump controller prototype functioning. It pushes water around. It does its job. I will have improvements for this build in future videos. And for the next video, I have an idea to build custom grow lighting instead of buying lighting. So if you like this video, please come back and watch the next one. And yeah, I hope everybody enjoyed this. Thanks.